Welcome to JSTube again. So in the previous video, or in part 1, we have prepared these 7 factors or 7 criteria for susceptibility mapping of a certain area or a study area. So we have reclassified these 7 criteria based on 1 to 5 ratings. So after classification, we have to show that the resolution and the projection of each raster must be the same. So then what we have going to do is combining these 7 criteria in weighted overlay to produce flare susceptibility mapping of a certain area. But in order to combine these 7 criteria, we have to know the weight of each value, because each criteria did not have the same weight value. So this is a multi-criteria decision-making analysis in GIS environment, which means considering multiple factors and going to decide the weight of each factors to bring in one factor and bring one influencing factors. So I will show you this analytical hierarchy process. This means multiple inputs. So as you have seen this, n is equals to 10 means number of criteria. In our case, it is what? 7 criteria. We have 7 criteria. So scale 1. So you have to write the number of criteria. So it assumes you have 7 criteria, but if you have 8 and 9 and 10 criteria, you can write this. So the objective is application of GIS-based multi-criteria decision analysis and analytical hierarchy process AHP in the flare susceptibility mapping. So you can write the dates, the criteria, the comments. Finally, the weight will be decided by this Excel. So this is a matrix. This is a matrix, and this is a normalized principal eigenvector. So this is totally gives weight. In other words, this is weight. So in this case, when we compare two factors each other, we have make sure that you have to use open discussions, previous similar research results conducted in a similar environment or in other country with similar environment and agroecological settings, and expert judgment must be important for your research or for your project, for all your project. So this is the summary part. Yes, and this one is the comparison. So analytical hierarchy process objective, as I told you, application of GIS-based multi-criteria decision analysis and hierarchy process AHP in the facility. Please compare the importance of elements in relation to the objective and fill in the table which element of the pair more important or B, and how much more on scale 1 to 9 as given below. Once completed, we might adjust highlighted comparison 1 to 3, improve consistency. So consistency ratio, we have called the consistency ratio. So first, let us write our factors. The first one is elevation. The second one is slope. The third one is rainfall. The fourth one is LUC. The fifth one is think NDVI. The sixth one is distance from river, let's say simply river. river, and the final one is distance from road. Let's say road. Yes. So it gives similar weights because we didn't make any comparisons against each other. So that once we have fit these criteria, we have to go to L1. So, for example, elevation against the slope A or B. A means elevation A 1 to 9. 1 means, see, here is the description. Yes. Start with scale of 1 equal importance, 3 moderate importance, 5 strong importance, 7 very strong importance, 9 extreme importance. Means the evidence favoring one element over another of the highest possible order of affirmation. So these are the intermediate values that going to assign in. So now let us come to this one, and let us compare. Yes. So elevation against the slope. So let us give one, that means equal importance, because one depends on another. So elevation against rainfall. Okay, B. So let us continue our comparison. Elevation against land cover. So A is more important. Yes, 3. Okay, great. Elevation against NDVI. A is more important. Okay, 5. Okay, great. Elevation against river. Okay. Equal importance. 1. Okay. So elevation against road. Yes. So let us go to equal importance. Okay, great. So slope against rainfall. So rainfall is greatest. Yes, great. So slope versus land is land cover. So slope is more. 3. Remember, 3 means more important. Slope against any device. So slope is more important. Okay, great. A slope against the river. So equal importance. As I said you, this judgment must be approved by indigenous knowledge, teachers, and rainfall against land is land cover. So rainfall is more important. Yes, rainfall anyway. Rainfall is more important. Yes. Okay. Rainfall against river. So rainfall against river equal importance. Rainfall against road. Okay. Equal importance. Let me select rainfall. That means create land use land cover against any DVA. Land use land cover is more important. Okay, land use land cover against river. River is more important. Yes. Land use land cover against road. Okay. Equal importance. Need pay against river. Okay. Need pay against road. Okay. Finally, river or road. So river is more important. Yes. So now let us return back to our summary. So we have to use this one. Yes. The summary of this weight must be 100. The sum of these weights must be 100. So sum is 100%. So elevation 16%, slope 40%, rainfall 24, land cover 8.2, any device 6.1, river 18.2, road 12.8%. So this is a great result, and the consistency ratio is between 1 and 0, so 0.37. It's great. So great amount has been achieved. So this automatic Excel sheet works the result, as you can see here. Yes, rainfall is the highest. The second one is a river, and continues as in order of importance. So finally, in order to combine these all factors, we have got these weights out of 100. So we have turned to. So finally, we have turned to this weighted overlay. Click Arc Toolbox. As I said, in order to combine these factors in weighted overlay, we have to know the weight of each factors out of 100%, and finally all 7 factors, the sum of all 7 factors must be 100%. 100%. So now just go to Arc Toolbox, then go to Spatial Analysis Tools, then go to Overlay, then go to Weighted Overlay. Yes. Then add raster. Yes. Elevation. Okay. So let us see when the order of importance is reciprocal against the increment of elevation. So 5, 4, 3, 2, 1. 1. Yes, let us add slope. Slope. Okay. The slope is also when slope increases. When slope increases, the flux stability become decrease. So it is also reciprocal. 5, 4, 3, 2, 1. 1 means very low susceptibility. 5 means very high susceptibility. The third one is rainfall. Yes. So let me see rainfall. So as amount of rainfall increases, susceptibility to food risk becomes increased. So this is the order of increase is good. So let me left as it is. The fourth one is land use land cover. Let me select land use land class input field. Yes. So vegetation is last. The first very low susceptibility. Water body is 5 susceptibility. Agriculture is the fourth one in order of susceptibility. Land is the third one, and settlement is the second one. The second one in order of susceptibility. Okay, great. So let us go to any DBA. Okay, when any DBA increases, let us check. When any DBA increases, when any DBA increases, the number of susceptibility decreases. That means there is dense vegetation. The susceptibility to flood becomes decreased. So let us make reciprocal to it. Yes. Let me change this one to 1. Okay, great. The fifth one is a river, distance to river. Okay. Let us check also distance to river. When distance is increasing, the susceptibility to flood becomes decreasing. So reciprocal relationship. Yes. Okay. Let us add the final variable or controlling factor rod. Okay. Great. Let us check also the rod. This is in meters. When the rod meter is high, then the susceptibility to flood is low. So let's return back to the rod. So let me make this reciprocal. This is the scale value and this is the field. So let me, for example, elevation. Let me bring from this 16. Yes, 16. The slope 14.4. Slope 14.4. Rainfall 24.3. 24.3. Land use land cover 8.2. 8.2. Any DVA 6.1. 6.1. Distance from river 18.2. 18.2. And the last one is 12.8 root 12.8. Now you can left other things as it is, and output cluster means the place where you save your output folder. So let me accept the default and click OK. The overlay is calculating. Let's wait some time. Okay, great. So this is, let us uncheck other things. Yes. Let us make some amendments on symbology. Let's make some amendments on symbology. The first one is very low. Very low. The second one is low. The third one is moderate. The third one is high. The fourth one is very high. Very high. Okay. So we have got such kinds. So let us add some mapping elements. Insert. Legend. Okay. Next. 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 Finish. Yes. Let us add another mapping element. Scale bar. We have added scale bar. Insert. North arrow. Yes. Okay. Here is north arrow. Okay. Insert. Title. There's a susceptibility map of study area. Let us make some amendments on this. Let us increase to 30, 36 for example. Apply. Yes. Apply. Okay. Let us make some amendments. So cartography is basically a makeup. So making a gestic of your maps. Yes, with overlay. Let us make some amendments on this symbology. For example, let me select this as a background. Yes. Or you cannot use as a background. It is based on your choice. Yes, let us select this one. Only labels. Apply. For example, 20. Okay, great. Yes. Legend. For example, let us make this as Karamut. Apply. Apply. Okay. So we have finished our mapping. Go to File. Export map. You can save as save and export. Click save. Okay. Get the map output. I have saved as output. This is output. So you can use the proportion. You can calculate the proportion of how much each scale covers. So you can calculate flexibility map of a certain area, a project, or a research based on certain criteria stated with analytical hierarchical process and multi-criteria decision-making analysis in ArcGIS. So this is what we have today. I hope you get important concepts and ideas how to analyze data in order to map flood susceptibility of a certain area. If you are new to this YouTube channel, please subscribe. Thank you for watching.